So today we have an easy geometrical problem. The diagram is on the screen. Now the question over here is to find the total blue area, that is the combined area of the squares. So this is Anmol Mishra, and now let us see the solution. How can we find the total blue area? So first of all, let us start the solution by marking some of the basic angles and the length of the line segment. So I will take the length of the smaller square as equals to a variable x. Now if the side length of this square is x, therefore area of this square becomes x square. Similarly, if I will take the side length of the bigger square as equals to a variable y, area of this particular square becomes y square. Now the question was to find the total blue area, so the total blue area now becomes x square plus y square. Okay. Now we know that in a square all the four sides are equal. This means all this four length would be equal and it would be equals to x. Similarly, in this square all the four sides would be equal and they all would have a length equals to y. Okay. Now let us mark the angles. So look at this particular point. This is the corner of the square, so 90 degree. This is also the corner of the square, therefore 90 degree. Now if I take this particular angle as equals to theta, what can you say about this angle? So as we can see, there is a complete angle over here. Therefore, addition of this, and this would be equals to 360. Therefore, if I take this angle as alpha, so what I will get as an equation is alpha plus theta plus the 290 angles over there, and this thing is 360. And when you will simplify this thing, you will get alpha as equals to 180 degree minus theta. Okay. So as I have told you many times that whenever you are solving a geometrical problem, try to exclude the variables. So as here we have got the value of alpha in terms of theta, so I'll replace alpha in terms of theta, that is 180 degree minus theta. Okay. Now what I will do is I will use the cosine rule. Now what it is, let us see it in a short form. Suppose you have a triangle and this angle is equals to alpha. Now the three sides of this triangle, we take it as capital A, capital B and capital C. Then as per the cosine rule, the value for cos of alpha would be equals to square of the adjacent added together, that is. Now in this diagram, this and this side are adjacent to angle alpha, therefore A square plus B square minus the square of opposite. So opposite to angle alpha is C, so minus C square upon 2 times the product of adjacent, so 2 times B times A. It's better to write 2 times AB. Okay. So in any triangle, the value for cos of alpha, that is one of the angle, would be equals to squares of the adjacent added together minus the square of opposite upon 2 times the product of adjacent. So the similar cosine rule we will first of all apply in this triangle and then we will apply in this triangle. So let us apply in this bottom triangle first of all. So the bottom triangle is like this, this and this. Here is the angle theta, and this side is the side of the smaller square, so it will have a length x. This side is the side of the bigger square, hence it will have a length y, and this length is given, that is equals to 3. So let us apply the cosine rule. So in this triangle, the value for cos theta would be equals to squares of the adjacent added together. Adjacent to angle theta is x and y, therefore x square plus y square minus the square of opposite, that is 3. So minus 3 square, that's 9 upon 2 times xy. That is 2 times the product of adjacent. So in this triangle, after applying the cosine rule, we got the value for cos of theta. Now let us apply the cosine rule in this upper triangle. So let me just draw the triangle how it looks. So the upper triangle is like this, this and this. This side of the triangle is ultimately the side length of the smaller square, therefore it would be equals to x. This side is the length of the bigger square, hence it would have a length y. And this length is given as equals to 7, and this particular angle is 180 degree minus theta. Now let us apply the cosine rule in this triangle. So we'll take our main angle is 180 minus theta. So cos of 180 minus theta, I'm going to use the cosine rule over here, would be equals to square of the adjacent added together. So adjacent to this angle is x and y, therefore x square plus y square minus the square of opposite, so minus 7 square, that's 49 upon 2 times product of adjacent, so 2 times x times y. So here we have got the value for cos of 180 degree minus theta. Now remember the trigonometric identity that cos of 180 minus theta is ultimately negative cos of theta. So the value for negative cos theta is x square plus y square minus 49 upon 2xy. and previously we have got the value for positive cos theta. So we can easily compare this equation. What I need to do is I need to just change the negative sign. Like here we have the equation for negative cos theta, so I will simply take negative on both of the sides. So negative of this side would be equals to negative of that side, so minus and minus becomes plus. So here we have again the value for cos of theta, and previously we were having the value for cos theta. So now we can compare the other side. So the other side of the first equation is x square plus y square minus 9 upon 2 times xy, and this thing is equals to negative of x square plus y square minus 49 upon 2xy. Now as x and y were the side length of the square and it cannot be equals to 0, so 2xy and 2xy, the complete term got cancelled out, and if I open this negative sign, so I'll finally get x square plus y square minus 9 as equals to 49 minus x square minus y square. And when you will simplify this thing, you will get that 2 times x square plus y square is equals to 49 plus 9, that's 58. So finally we'll get x square plus y square as equals to 29, and that's the answer that we were looking for. So x square plus y square is equals to 29 unit square is the correct answer. Okay, so this was my way to solve this particular question. If you have any other method other than this, do comment below, and if it's hard to comment, you can email me, or else you can send it to me on my Instagram. The link is in the description.